about introduction to finite element analysis, or you can say the finite element method. As already we have discussed about the difference between finite element analysis and finite element method. So finite element analysis, this is related to industrial part, and finite element method is related to your academics. Okay, so this is the difference, basic difference between FEA and FEA. So FEA is nothing but finite element analysis. Actually, for this, we are going to use some softwares like ANSYS, Hypermesh. There are various types of softwares that can be used for analysis. So these are, first one is ANSYS, second one is Hypermesh, which are user friendly. The next is Nastran, which is used for your aerospace applications. Then next is LS-DYNA. LS-DYNA, it is used for your vibration analysis. So these are there are 5 to 6 softwares that can be used to analyze. Means if the static problem is there, then we can use our Hypermesh or ANSYS. If dynamic problem is there, then we can use the LS-DYNA problem. And if the vibration, means aerospace problem is there or aerospace application is there, then in that case we can use Nastran. So there are 5 to 6 softwares which are related to your finite element analysis. But for academic purpose, we are using only 2 softwares. First one is ANSYS and second one is Hypermesh, because these are user friendly softwares. So we can use these softwares to analyze our static as well as dynamic problem. Or similarly, we can use this for temperature analysis also. Okay. Actually, finite element analysis, this is related to your static and dynamic problems. And computational fluid dynamics, this is your second elective, second option for first elective. So this subject is related to your fluid properties or fluid analysis. You can use this computational fluid dynamics subject. For this, there are also various softwares like ANSYS Fluent is there. Okay, so in this way, these softwares can be used according to the application. Means if static application is there, then we have to use Hypermesh or ANSYS. And if the dynamic applications are there, then we have to use the LS-DYNA. Actually, there are 2 types for using this these softwares. First one is pre-processor. Second one is post-processor. So pre-processor means you have to give inputs of all boundary conditions. You have to mesh the given geometry. Then these inputs can be given to the post-processor. So for post-processor, you can use another software. Like actually pre-processor, your Hypermesh software is pre-processor and ANSYS software is your post-processor. Means in Hypermesh, you can do the meshing part, or you can apply the boundary conditions, or you can convert the whole geometry into infinite number of elements by using this Hypermesh software. Then you can import this geometry into ANSYS and you can do the stress analysis or displacement analysis or whatever you want. Means vibration analysis is there, temperature analysis is there also. So now we will see the basics of finite element analysis. Okay, just wait a minute. I have to admit all the peoples right now. So just wait a minute. Okay. So we will see right now the introduction of the finite element analysis. Okay. So 1 minute. Okay. So right now we will see the finite element analysis. What is the concept of finite element analysis? As we know that there are analytical methods, as in case of your strength of material, in case of your heat transfer problems, in case of your machine design problems. Also, if you take any subject, there are some basic principles. Okay, for suppose for strength of material, there are 3 to 4 topics. Means as you know that First topic contains your simple stresses, simple strains and displacement. Second topic contains your bending problems, means bending stresses. Then third one includes your buckling problems. So in all your topics or in all your units, there are some basic principles. Okay. So by using these basic principles, you can find out the stresses, various types of stresses, like your tensile stresses, compressive stresses, bending stresses, or buckling stresses, or compressive stresses. Okay, so this can be calculated based upon your basic principles. Okay, means, but in that case, you observe that your geometry is uniform. Uniform means the cross section of the geometry is uniform. Then and then only you can apply these all principles. Okay, understand? Actually, what I'm saying that if the geometry is regular, regular means what? If the cross section area of that part is uniform, then and then only you can use this basic strength of material principles. Like suppose if we take one example of a cantilever beam. Okay, suppose if we take this example. So in that case, one end is fixed and another end is free, and at this another end, one load is applied in a vertically downward direction. Okay. So now in that case, this beam is of uniform cross section. Okay. Let us assume another example of tensile load acting on a rod. A circular rod is there, and a one tensile force of 100 kilonewton is acting in horizontal direction at right end, and left end of this circular rod is fixed on. So in this case, if you are asked to find out the stresses applied at the end due to this externally applied load of 100 kilonewton. Okay. So in this case, you can simply apply your basic principles to find out the stresses acting on this rod due to this 100 kilonewton force. Okay. So in this case, you can use the formula. So formula is nothing but stress is equal to force upon area. So force is nothing but this given externally applied load of 100 kilonewton, and area is nothing but you can find out the cross sectional area, because this cross section is circular. Okay, wait 1 minute. I'm admitting some people. Okay, because this cross section is circular, and on this particular area, this force of 100 kilonewton is acting. Okay, so in this way, you can find out the stress acting at the end of this rod. Okay, so by using this formula, stress is equal to force upon area, you will get the stresses. But now, if I change this cross section to a tapered geometry. Okay, suppose if I change this cross section, actually in previous case, this cross section is uniform. Okay, so you can use your basic principles of strength of material to find out the stresses. Now, if I change the cross section to a tapered geometry, so do you understand a tapered geometry? Tapered geometry means one cross section is small, and at another end the area is different from another section. So if I am fixing your left end of this rod has bigger area, and at the right end this rod has smaller area. So if I use this rod, means this tapered rod, for your analysis, now you cannot apply the basic strength of material theories to find out the stresses acting at any point on this rod. Why? Because there are some limitations. So these limitations are cross section of the part or of the rod should be uniform. It should be uniform means your cross sectional area, it should be uniform throughout the section. Then and then only you can apply your strength of material theory to find out the stresses acting on that material. But now if actually I'm changing the cross section to a tapered geometry, so in that case you cannot apply these principles. You can apply these principles by assuming some assumptions. Means you can do some you can assume that you will take the average area, means cross sectional area. Suppose at right section this is a1 and at left section this is a2, then you can take average area is equal to a1 plus a2 divided by 2. So you can use this average area for your calculation. But by using this average area, hello, yes, please, hello, one minute. Okay, hello, am I audible now? येतोय का आवाज आता?
येतोय सर.
येतोय ना? की लॅग होतोय? ओके ठीक आहे, म्यूट करा फक्त तुमचं सेशन तिकडचं. ओके ठीक आहे. सो कुठे होतो आपण? Okay, so you can use this formula by using you can find out the stresses by using this average area, but you can get approximate solution. In this case you cannot get exact solution. Okay, so there is a need to develop some technique to find out the exact stresses when the geometry is different than the uniform cross sections. Actually uniform cross sections means if we use circular bar, if we use a rectangular bar, if we use a triangular bar, this cross section will be uniform in this case. So we can apply our basic strength of material theories in that case. But if the cross section or geometry changes, then we cannot apply our basic theories of strength of material. So in that case, we need to develop some technique, some another procedure to find out such type of problems or to solve such type of problems. So there is a technique which is called as finite element analysis. Okay. So finite element analysis, it is also a numerical technique. This is also a numerical method for solving problems of engineering as well as mathematical physics. Okay, actually in traditional or in conventional, you can use your analytical solutions. Analytical means your basic strength of material theories or principles. These are called as analytical solutions, and because actually we have derived some formulas from these analytical methods, and by using these formulas you can get the solutions. But the finite element analysis, it is similar to the analytical solutions, but it uses a numerical method to find out or to solve the engineering problem. So now how we are going to solve such problems, we will see in detail. So next is, okay, this is the purpose of the finite element analysis. So as in previously we have discussed about the analytical solution. So let's see the stress analysis for stresses. Truss is nothing but a uniform cross-sectional element. Beam is also a uniform cross-sectional area, but beam cross-sections may be triangular, may be rectangular, may be circular, and other simple structures are carried out based on the dramatic simplification and idealization. So idealization means what? Assumptions काय बनवलेत त्यांनी? Mass should be concentrated at the center of gravity. Assumption first is that मास आपण काय समजतो की मास त्याचं सेंटर ऑफ ग्रॅव्हिटीला कॉन्सन्ट्रेट केलेला. सेकंड अजम्पशन काय असतं की बीम इलेमेंट और युअर रॉड इलेमेंट और युअर शाफ्ट इलेमेंट इट इज सिम्प्लिफाइड ॲज अ लाईन सेगमेंट और सेम क्रॉस सेक्शन. मी काय म्हटलं होतं बघा, युनिफॉर्म क्रॉस सेक्शन मीन्स सेम क्रॉस सेक्शन. दिस इज युअर सेम क्रॉस सेक्शन. हे जे बेसिक अजम्पशन्स आहेत ते तुमच्या स्ट्रेंथ ऑफ मटेरियल थेअरीसाठी अप्लाय होतात. मीन्स यू कॅन यूज based on these assumptions, you can apply your basic principles of strength of material, whether it is strength of material or heat transfer or vibration analysis. These some basic principles you have to use, but there are some limitations because See, this beam is simplified as a line segment. Means what? The area or cross section should be uniform. Cross section should be same, means it should be uniform throughout the section. Okay, so if we suppose if we use another section which is not uniform, then we cannot apply our basic principles. So we need to develop some techniques, and this technique is nothing but your finite element analysis. So finite element analysis, in finite element analysis, we will solve the design geometry, which is lot more complex. Lot more complex means such like a tapered section. Okay, actually this concept is come into account because of the aerospace problems, because aerospace applications there are some lot of complexity in the part. Lot of complexity means more irregular parts are there, and due to these irregular parts we need to, if we need to find out the stresses applied on this irregular part, then we need area. जर आपल्याला स्ट्रेस फाइंड आउट करायचा असेल तर त्या इरेग्युलर पार्टचा आपल्याला एरिया फाइंड आउट करावा लागेल. इरेग्युलर पार्टचा एरिया कसा फाइंड आउट करणार? एरिया आपण कोणता फाइंड आउट करू? जो युनिफॉर्म क्रॉस सेक्शन असेल त्याचाच आपण एरिया फाइंड आउट करू शकतो. सो बट these aerospace applications or aerospace parts has irregular geometries, and in that case we cannot apply our basic principles because we need area. 1 minute. Okay, we need one specific area. If the cross section is of circular, rectangular, triangular, or you can say trapezoidal, then in that case you can find out the area. But for aerospace problems or aerospace applications, if there is a irregular geometry, then we cannot find out the area. In that case we can take average area, but you will get in this case approximate solution, but we need exact solution. So for this case there must be another application or must be another procedure to find out the stresses acting on this irregular geometry. So to find out this stress analysis or vibration analysis or heat transfer analysis, we need to develop some technique, and this technique is nothing but your finite element analysis. Okay, so look at this. This finite element analysis, it is applicable to more complex as well as when the accuracy requirement is lot higher, then we can use the finite element analysis. So similarly, this is used to understand the physical behavior of a complex object. So actually output आपल्याला काय काय हवं असतं, कशासाठी आपण डिझाइन करतो, तर फर्स्ट जर स्टॅटिक प्रॉब्लेम असेल देन वी कॅन चेक इट फॉर स्ट्रेंथ. जर हीट ट्रान्सफरचा प्रॉब्लेम असेल देन वी कॅन चेक इट फॉर हीट ट्रान्सफर कॅपेबिलिटी. अँड इफ द प्रॉब्लेम इज ऑफ फ्लुइड मेकॅनिक्स or if the problem is of any fluid related equipment, then we can check it for fluid flow. Okay, so these are the outputs: strength, heat transfer capability, and fluid flow. 1 minute. Okay, so based on these outputs you can develop one new method to find out the solutions related to your irregular geometries or more complex problems. So first one, let us see here. First one is your strength. So strength is related to your static problem or structural problem. Now second one is heat transfer capability. Now this is related to your heat transfer problems. Okay, actually in your previous subjects you have studied about strength. You have studied about various properties related to your strength of material. Similarly, you have studied about various properties of the heat during your heat transfer problems. Similarly, you have studied about fluid properties also. Now, similarly, we can develop some new technique for each segments. So for strength, there is a finite element analysis approach. For heat transfer capability and for fluid flow, there is another subject which is called as computational fluid dynamics, which is your second option of your first elective. Okay, so first option is your finite element analysis, which is related to your structural as well as dynamic analysis. Second option is your computational fluid dynamics. If you have interest in the fluid dynamics or heat transfer problems, then you can choose computational fluid dynamics, CFD. In that case also you have option to choose some softwares Similarly, as we have seen, our for structural analysis there are 4 softwares. Similarly, for heat transfer or fluid problems there are also some 3 to 4 softwares. So if your interest is of structural, then you can use finite elements. Then if you are interested to analyze your fluid flow or heat transfer problems, then you can choose your CFD or computational fluid dynamics problems. Okay, so but the output is that, or outcome of this subject is that we are using, or we are developing some new procedure to find out the solutions to irregular and more complex problems. Okay, so outcome of the FEA or outcome of the CFD is same, and this is nothing but we are applying this procedure to more complex and irregular properties where we cannot apply our simple principles, our basic principles, because there are some limitations, and due to these limitations we need to develop some another procedure or another technique. So there are, first one is your FEA, finite element analysis, and second one is your CFD, computational fluid dynamics, and these are the options for your elective one. And third option is nothing but heating, ventilation, and air conditioning. This is another part actually. But this FEA and CFD, these are the two parts or two new techniques which have same outcome, and we are, why we are applying this, because of some limitations to complex geometries or irregular geometries we are applying the FEA and CFD. This is the main motive of our subject. Okay, now we will see how to apply this procedure in detail right now. Okay, so FEA, this is used to design geometry which is lot more complex, and if we need the accuracy, higher accuracy, then we use the FEA. Okay, to predict the performance and behavior of the design, to calculate the safety of margin. Now here we will discuss about the safety margin. Safety margin means your factor of safety. Now I will explain one example regarding this. Okay, so regarding factor of safety, now there is a section. Suppose if we take our previous example. Okay, so uh, for previous example, we have used our cross section as rod. One simply supported rod if we use, for this simply supported rod, if the force is applied on its center and its value is equal to 1000 kilonewton. Okay, and this rod, weight of this rod is suppose 10 kilonewton. Suppose weight of this rod is equal to 10 kilonewton, but this weight of this rod is 10 kilonewton is given depending on your factor of safety. But if our requirement is to optimize the weight of that material, actually we are going to find out the stresses due to these forces, and based on these stresses or ultimate strength, we are going to finalize the weight of that material. But 1 minute, 1 minute. But now instead of this simple basic strength, simple strength of material theory, if we use our finite element analysis, then there we will get some safety margin. By using this safety margin, we can reduce the weight of that material. Means actually we have given extra weight to sustain this force, but by using our finite element procedure, we can reduce or we can optimize some weight of that material, and this is possible by using this finite element procedure. Okay, so this is the weight optimization of the material. We will see in detail in our next second or third unit. These all things we can apply during your second and third unit. Okay, so this is then next third one is to identify the optimal design with the confidence. This is the same thing. Means if we want to optimize the weight, or if we want to optimize any property of that material, then we can use our finite element analysis procedure. Okay, now next, now this is the brief history. Now brief history is means actually I have discussed with you that this concept came into account due to the aerospace industries, because in aerospace industries there are lot of irregular geometries, and due to this, we if they are asked to find out the stresses and vibrations, or if they are asked to do the stress analysis or vibration analysis for this irregular geometry, then we cannot able to find out the stresses, means exact stresses. We can find out the stresses, but we cannot find exact stresses. We can find out approximate stresses by using average area method, but we need exact stresses. So there is a need to develop this technique, and this is nothing but your finite element analysis. So this second thing is, actually this is applied to these jets, missile, space flights, because due to this irregular or complex geometries, we need to develop some techniques. The next is, third one is due to lightweight structures, means if we want the lightweight structures, means if we want to optimize the weight of that material or weight of that part, then we have to create new procedure. This is nothing but your finite element analysis. The next one is accurate stress analysis. Okay, because accurate stress analysis means what? Because in case if we apply our simple strength of material theories, then in that case you have to assume some average area. Then by using this average area you will get some stresses, but these stresses are approximate. You cannot get accurate stress analysis in that case. So to have accurate stress analysis, we have to develop one technique. The next, parallel growth of computers, means by using softwares you can easily analyze the structural problems as well as vibration problems. Okay, this is the brief history of the finite element analysis. फक्त हे समजून घ्या की कशामुळे त्याची गरज आहे, एवढं फक्त लक्षात घ्या की गरज का आहे या गोष्टीची. फायनाईट एलिमेंट अनालिसिस करायची गरज का आहे? का तर आपले जे बेसिक प्रिन्सिपल्स आहेत ना, स्ट्रेंथ ऑफ मटेरियलचे असतील किंवा हीट ट्रान्सफरचे असतील किंवा व्हायब्रेशनचे असतील, आपल्याकडे आता सध्या बेसिक प्रिन्सिपल्स आहेत, ते फक्त कुठे अप्लाय होत आहेत? सिंपल जॉमेट्रीला, ज्या की युनिफॉर्म आहे, त्याचा क्रॉस सेक्शनल एरिया युनिफॉर्म आहे, त्याच केसमध्ये तुम्ही ते अप्लाय करू शकता. बट जर इरेग्युलर जॉमेट्री आली, सपोज कॉम्प्लेक्स पार्ट आला, तर त्या केसमध्ये आपण अजम्पशन्स करतो की ॲव्हरेज एरिया घ्यायचा किंवा फोर्स ॲव्हरेज घ्यायची. तर ते न घेता we can apply finite element procedure to find out the stress analysis or vibration analysis of such irregular geometries. Okay, this is the basic use, or this is the basic need to develop the finite element procedure, and this basic need comes into account due to the aerospace industry problems. Okay, कारण एरोस्पेस मध्ये मोस्ट ऑफ द पार्ट्स आर ऑफ इरेग्युलर जॉमेट्रीज, आणि त्या इरेग्युलर जॉमेट्रीचं जर अनालिसिस करायचं असेल तर त्या केसमध्ये आपल्याला एखादी नवीन टेक्निक हवी होती. म्हणून फायनाईट एलिमेंट अनालिसिस हा सब्जेक्ट तुम्हाला ऍक्च्युअली आलेला आहे, म्हणजे इट विल कम इन टू अकाउंट ड्यू टू दिस एरोस्पेस इंडस्ट्रियल पार्ट्स विच आर इरेग्युलर इन जॉमेट्री. ओके, नाउ नेक्स्ट वन इज, these are the common applications of finite element analysis. Okay, so first one is mechanical or aerospace or civil or automotive, means these are the structural FEA is used for structural analysis. The next one is structural or stress analysis, means it will include the static or dynamic. Similarly, linear or non-linear. Actually, we will see in this we will see in detail what is this static or dynamic analysis, what is this linear and non-linear analysis. Then next one is fluid flow. For fluid flow, we can use finite element analysis as well as you can use the computational fluid dynamics also here. For heat transfer, same, FEA is also applicable, CFD is also applicable. Similarly, for electromagnetic fields, only FEA is applicable. Electromagnetic fields, these problems can be solved by using finite element analysis, means by using our ANSYS or hypermesh. Then solid mechanics, this is a structural problem, means we can use our ANSYS or hypermesh. Then acoustic, for acoustic, Nastran is the software to use to solve such problems related to your acoustic. And biomechanics actually it is the part of CFD, computational fluid dynamics. Okay, so these are the various types of common applications where we can use our finite element procedure. So there are two approaches. First one is finite element procedure, and second one is computational fluid dynamics. So first approach, it is basically related to your structural and dynamic problem. And second approach is related to your fluid properties as well as heat transfer problems. So best depending on your interest, you can choose FEA or CFA. Okay. So and third elective is your heating, ventilation and air conditioning. I think तो वेगळाच पार्ट आहे, या दोन्ही पार्ट पेक्षा तो पूर्णपणे वेगळा पार्ट आहे. सो this is our introductory part of finite element analysis. Okay, so we will conclude our this session here. So if you have any doubt, you can message me personally, or if you can have any doubt, then you can message करा किंवा तुम्ही डायरेक्टली विचारू शकता. आपण आता हे सेशन इथे संपवतो. डाऊट असतील तर सांगा, नाहीतर आपण कन्क्लूड करू. मग असंही टायमिंग झालेलंच आहे.